Hi, everyone. So this is the last part of this unit. Up to this point, we've been writing chemical equations and we've been balancing them. Most of the work that we've been doing is just balancing the chemical equations given. Now I'm going to give you some words that describe chemical reactions, and then you're going to write the chemical equations that go along with that. We're not going to spend very much time on this. I won't be giving you super complicated word problems, but I would like you to be able to write chemical equations if given a word description. I'm going to run through a couple of examples, and then we're going to go to the worksheet that I've assigned for this just to get you started, and this will be due for the next class period. All right, so here's our first example. We're going to take hydrogen gas and we're going to react it with oxygen gas to form water vapor. The first thing that we have to realize here is that hydrogen and oxygen are diatomic elements. Now, we actually started this unit by talking about the diatomic elements, and now it's going to really become important that you recognize that. Hydrogen is diatomic, so that's H2. Oxygen is diatomic, so that's O2. They react to form water, H2O. Okay? Now, it's really important that we get these formulas correct. Okay? We know that water is H2O. We've known that forever. But it's important to remember that oxygen is a diatomic element. The oxygen that you are breathing right now is diatomic oxygen. Hydrogen is a diatomic element, so that's H2. Remember, I gave you a really dumb way of remembering which are the diatomic elements, and I call them Hankel-Briff elements. Maybe we can just run through that real quick. Okay, so here are the Hankel-Briff elements, the diatomic elements, or if you like to call them the happy seven elements. Remember, if you look at the periodic table, oxygen through nitrogen through iodine through fluorine, that they kind of form a 7 on the periodic table. All right, so hydrogen is diatomic, oxygen is diatomic, so is nitrogen, chlorine, bromine, iodine, fluorine. You have to remember that. All right, my next step here now is to balance the equation. I cannot change the formulas. All I can do now is add coefficients to balance the equation. And if we balance it, we'll come up with 2 hydrogen molecules for every 1 oxygen molecule to form 2 molecules of water. And that's all there is to it. That is our first example. Let's try another example. All right, so here's our next example. We've got potassium metal reacting with liquid water to form potassium hydroxide and hydrogen gas. All right, I'm going to write out our chemical equation. At least we'll start with the skeleton equation. Okay, so potassium has the symbol K, so this is potassium. Now, I could include in here the fact that it's solid. That's not really very important, but, it's a little extra information. I'm not saying you have to do it, but I'm just going to include that into our equation now because we're starting with solid potassium metal, okay? It's going to react with liquid water. All right, H2O. Now, it's liquid, so I'm going to include the fact that it's liquid. It's not a big deal, but there you go. All right, we're going to form potassium hydroxide. All right, what is the formula for potassium hydroxide? I hope you agree with me that this is potassium hydroxide. We spent a lot of time writing formulas from names, and this is an example of that. So potassium hydroxide. We're not given the form that it's in, so I'm just going to leave it. We don't have to include the phase of it. It's actually an aqueous solution, but let's not worry about that. And we're going to form hydrogen gas. All right, now hydrogen is a Hankel-Briff element, so that's an H2. All right, it's a diatomic element, H2. Now we need to balance this. Okay, now here's the deal. I told you that there's a little trick that we can use. We've got water on one side of the reaction, we've got hydroxide and hydrogen on the other side of the reaction. Okay, I could rewrite this in this way. Okay, I rewrote this. We've got solid potassium we have solid potassium. We've got hydrogen hydroxide, which is water. Hydrogen and hydroxide. It's a little trick that we can use to balance this. Here we've got, this is potassium hydroxide, and this is hydrogen. Okay, now, how many waters do we need now? We've got hydrogen here, one hydrogen. We have two hydrogens here. We have one hydroxide here. We have one hydroxide here. In order to balance this, I'm going to say I need two waters. If I have two waters, that means I have two hydrogens here, okay? And I have two hydrogens here. I have two hydroxides here. I have one hydroxide here, so we need to fix that, all right? That means we need two KOH. We have two hydroxides. We have two potassiums on the right side. We need two potassiums on the left side. And now we are balanced. Okay, these are the steps you need to always follow when you're doing this. Start out by writing the skeleton equation, okay? Just the proper formulas, and then balance the equation using coefficients, okay? Once you've written your skeleton equation with the proper formulas, you cannot change those formulas, okay? The only thing that you can do to balance the equation is to change the coefficients, okay? Let's go to the worksheet now and let's get you started on that. All right, so here is the worksheet, and I want to get you started on the first problem, okay? And I don't know, maybe we'll do another one. Let's start with this one. All right, I'm going to write out my skeleton equation. Nitrogen gas. Nitrogen gas. Nitrogen is a diatomic element. It's one of those Hankel-Briff elements. Okay, I'll just leave the gas part of it out. Okay, and let's just write N2 plus. Okay, hydrogen gas. It's also a diatomic element. It's a Hankel-Briff element. These guys react to form ammonia, NH3. There's my skeleton equation, all right? I've got the formulas written. They're proper formulas. Now I cannot change those formulas. All I can do is add coefficients to balance the equation, okay? All right, well, on the left side of the equation, I've got two nitrogens. I only have one nitrogen on the right side. I'm going to add a coefficient of 2. Now I've got two nitrogens. But now I have 6 hydrogens on the right side. So I need 6 hydrogens on the left side. And there's our balanced equation, and we're done. Okay? If I wanted to add the states of matter in there, I could say, okay, that's nitrogen gas. This is hydrogen gas, and we're forming ammonia gas. All right. The states of matter are not that important, but I thought, what the heck, we can just throw it in there. All right, let's try one more. Let's go to the bottom of the worksheet. I'm going to go to number 5, and I want to talk this one through with you a little bit. I wrote a little note there saying, read this one carefully first, and then write the chemical equation. Why don't we do this together right now? I'll read through this and then let's solve this. All right, so we're going to take carbon disulfide and it's going to form carbon dioxide and sulfur dioxide when it reacts with oxygen gas. In other words, the carbon disulfide is going to react with the oxygen gas to form carbon dioxide and sulfur dioxide. We need to be a little bit careful when we're solving this because we need to see that part of what's reacting comes at the end of the sentence. So oxygen gas reacts with carbon disulfide. Let's write that out. Okay, carbon disulfide. Remember, carbon, sulfur, that's carbon disulfide. That's a molecular compound. And remember, the di means two. So carbon disulfide reacts with oxygen gas. Remember, oxygen is one of those diatomic elements. So O2. All right, they're going to react to form carbon dioxide and sulfur dioxide. Okay? Now we need to balance it. Now the formulas are all written correctly. I'm going to say it again. You cannot change the formulas once you've written proper formulas. Now all we can do is change the coefficients to balance the equation. Okay, let's balance this. Carbon disulfide on the left side. We have sulfur dioxide on the right. We have two sulfurs on the left, one on the right. I'm going to need to change this coefficient to 2. Now I have 2 sulfurs. Okay. What about the oxygen now? I have 4 oxygen plus 2 oxygen is 6 oxygen. So I am going to need 6 oxygens on the reactant side. We are now balanced. We have 1 carbon, 2 sulfurs, 6 oxygen, and now we're balanced. And the rest is up to you. Good luck with this. This is due during our next class period.